Welcome back to Calculus Conundrums by the Perfect Square. Feel free to subscribe to my videos if you like what you see. In this one we're going to continue with implicit differentiation, and we're going to throw in some natural log functions. Now this first one is pretty straightforward. You know that if you take the derivative of the natural log of u, you're going to get 1 over u times u prime. Well, since this is y, when I take the derivative of the natural log of y, I'm going to get 1 over y times y prime. And then when I take the derivative of 5x, it's going to just give me 5, and the derivative of the constant 30 is just going to give me 0. And now all I have to do to solve for y prime is subtract 5 from both sides, so that'll give me a minus 5 over here. And then I can multiply both sides by y to get y prime. So y prime would simply be minus 5y. Okay? That one was a pretty simple one here. Now, the next one here is a little more complicated. So here I have the natural log of x squared y minus 1 equals 2x minus 3y. So I'm going to apply the derivative to each. So I'm going to take the derivative of this natural log, and then on the other side I'm going to take the derivative of 2x with respect to x, and I'm going to take the derivative of 3y with respect to x. So let's do the right hand side first, because that's pretty easy. So if you take the derivative of 2x with respect to x, you'll just get 2. And if you take the derivative of 3y with respect to x, you'll actually get 3y prime. Because remember, when you take the derivative y with respect to x, since we don't know what y is, we have to call that y prime. Okay, now, what about when I take the derivative of this natural log? Well, remember, the derivative of natural log of u is what? It's 1 over u, which would be this, right? That would be 1 over u. That's 1 over the argument. And then times the derivative of the argument. So then I would have to multiply it by the derivative of that argument. Okay, so this right here, we need to find the derivative of x squared y minus 1 now. So now x squared y minus 1, I can use the product rule for x squared y. So I do x squared times the derivative of y, which would be x squared times y prime, and then y times the derivative of x squared, so that would just be y times 2x. And then I'm just bringing these two terms down. Now I'm going to have to do something here, and so let me show you what I'm going to do. Let me set it up for you. So what I want to do is I want to get rid of this denominator right here. So I can get rid of it by just multiplying this side by x squared y minus 1. And then that way, when I do that, that will cancel with this, and then I'll just be left with this part right here, x squared y prime plus 2xy. Now, but of course, if I multiply the left-hand side by x squared y minus 1, I got to multiply the right-hand side by x squared y minus 1. Now, I'm not going to do this algebra for you for time constraints, but just FOIL this, 2 minus 3y prime times x squared y minus 1. You can just FOIL these together. And when you FOIL those together, you're going to get these 4 terms right here. And then I just went ahead and brought this down. So I have x squared y prime plus 2xy on the left. Now, look for the y prime terms. There's a y prime term. There's a y prime term, and there's a y prime term. So get those 3 y prime terms on the left of the equal sign. So I get x squared y prime on the left. When I move this minus 3x squared y prime, that'll give me a positive 3x squared y prime. And then when I move the plus 3y over, that'll give me a minus 3y prime, I meant to say. And then, of course, I have 2x squared y here. But I need to get rid of this term, so I need to move it to the right hand side, and so that'll give me, oh, I almost lost my 2 there. So I have 2x squared y minus 2, so there's those 2 terms. And then when I move this term, the 2xy over to the other side, I get the minus 2xy. finally, I can now, if you look at these three terms, all three of them have a y prime in them. So now I can factor out the y prime. And when I factor a y prime out of this, I get x squared. Factor a y prime out of this, I get 3x squared y. Factor a y prime out of this, I get minus 3. So now all I have to do is divide both sides by this stuff in the parentheses here. So just divide both sides by this stuff here, and then I would get all the terms on the right divided by all these terms over here on the left. So I get 2x squared y minus 2 minus 2xy divided by x squared plus 3x squared y minus 3. And so that's the derivative. And if you did research implicit differentiation like I asked you to, then you saw that many times the derivative, when you find the derivative, it'll be given in terms of both x and y. And I probably should have told you that earlier, but again, I figured you could look it up. Okay, now let me go through this. I may not have time to do all of these, but let me try to get at least a couple of these done. Okay, so here I have an expression e to the xy plus x squared minus y squared equals 10. And so you can see this involves an exponential expression. So if I hit each term with the d over dx to take the derivative, then the derivative of e to the xy, remember the derivative of e to the u is e to the u times the derivative of u. And then the derivative of x squared we know is just 2x. Using the general power rule here, the derivative of y squared would be 2y prime, and then the derivative of 10 would just be 0. Now, I need to go ahead and find the derivative of xy, and we've already done that a couple times, so we know that's going to be xy prime plus y. And now let's distribute the e to the xy through these two terms, so I'll get e to the xy times xy prime plus e to the xy times y. Now let's find the terms that have the y prime in them. So there's a term with y prime. And let's see if I can find another term with y prime. There it is. So I want to keep those two terms on the left. And so if I keep those on the left, now I actually left out a step here, but let me see if I can talk you through it. I'm going to have to take these two terms and move them to the other side of the equal sign because they don't have the y prime. So when I move these two terms over, the 2x will become minus 2x, and the e to the xyy will become minus e to the xyy. And then that'll just leave me with these two terms that I've got boxed in these rectangles. And so if you factor the y prime out of these two terms, it will leave you with the first term. It'll just leave you with x times e to the xy for there. And then if you factor the y prime out of here, it'll leave you with minus 2y. And then finally, to isolate y prime, we can divide both sides by this, x e to the xy minus 2y. So if we divide this into the right-hand side, that will give me my y prime. So there's my y prime. Okay, here we have e to the x cubed. And I'm bringing in a trig function, so if you don't have trig, you can skip this. So I'm going to take the derivative of the term on the left and the derivative of the term on the right with respect to x. So we know to take the derivative of e to the x cubed, that would just be e to the x cubed times 3x squared. And then remember the formula for sine of u. To take the derivative of sine of u, you would actually have cosine of u and then times the derivative of u. So I multiply by the derivative of x squared y. Now, what's the derivative of x squared y? I have to use the product rule. So take x squared times the derivative of y, that'll give me x squared y prime. And then take y times the derivative of x squared, and that'll give me 2xy. Okay, now what did I do next? I distributed this cosine here through the inside the parentheses. So if I just multiply cosine x squared y times x squared y prime, I'll get x squared y prime times cosine x squared y. And then if I multiply the cosine term times the 2xy, I'll get 2xy times the cosine of x squared y. Now, I only have one term that has y prime in it here. Let's see if I can highlight it. That's the only term that has y prime in it. So what I'm going to do this time, I'm actually going to leave this term on the right hand side. So you can see I left it over here on the right hand side. And then I'm going to take this term and move it to the other side, and there it is. It becomes minus when I move it to the other side. Now, I want to isolate the y prime, so all I have to do is divide by the x squared cosine x squared y. And if you want to move that, move the y prime over here if you want to, if that makes it easier for you, and then just get rid of that. So, and then just, get rid of it there. So that way you can see, to solve for y prime, I have to divide both sides by all of this, x squared times the cosine of x squared y. And so here you can see I divided that into these two terms, and so now I have y prime isolated. Okay, let me do this one, and then I'll let you watch this one here, because I probably won't have time to do both of them. Alright, so let's say I want to implicitly differentiate this one, sine y equals x. Well, then I'll take the derivative of sine y. Now remember, the derivative of sine u is cosine u times u prime, so the derivative of sine y would be cosine y times y prime. And then the derivative of x with respect to x is just 1. So then I can solve this for y prime, and I get y prime equals 1 over cosine y. Now, let me show you something here. If you go back to the original function, you know that it says sine y equals x. So think of that as x over 1. So here's a triangle, a right triangle, and this is the angle y. Now remember, sine is opposite over hypotenuse. So if sine of y is x, that means the opposite angle has to be x, and the hypotenuse has to be 1. And then using the Pythagorean theorem, we can find a value for the other leg. That would just be square root of 1 squared minus x squared, or square root of 1 minus x squared. Okay, now I can actually find out what is cosine y. So cosine of the angle y would be adjacent over hypotenuse, so that would be square root of 1 minus x squared over 1, or just square root of 1 minus x squared. So now I know that cosine y is simply the square root of 1 minus x squared, and since y prime equals 1 over cosine y, then that would be the same as 1 over square root of 1 minus x squared. And so this is actually one way to find the derivative of inverse trig functions. Now you can do something similar here, but I won't have time to finish it. But if I take the derivative of cotangent y, I get minus cosecant squared y times y prime, and then the derivative of x is 1, the derivative of y with respect to x is y prime, and then if you get your two y prime terms together, this minus cosecant squared y prime and the minus y prime, I can move it to the other side, and I get y prime minus y prime cosecant squared y equals 1. And then if you factor out the y prime, you get y prime times 1 minus cosecant squared y equals 1, and then just divide both sides by 1 minus cosecant squared y. Now it turns out that 1 minus cosecant squared y is the same as minus cotangent squared y, so you'd have 1 over minus cotangent squared y, which is actually the same as saying minus the tangent squared y. And so there, that's your derivative in simplest form. Y prime equals minus tangent squared y. Alright, so that pretty much covers implicit differentiation. I do have one short video that I'm going to have to add here, and it's how to find the derivative of when you have a function of x raised to a function of x. And we'll cover that in the next example, and then that will end all of my videos in the Calculus Conundrums on derivatives.